Question 1d is again giving us another equation to start off with and asking us to find the derivative of it. The first thing that's really important to note here is they say where c is a constant. So anytime they tell us something is a constant, that means you want to treat it like a number. So anytime you see a c in this equation, think of it like a 5. It's not a variable. You're not going to be taking the derivative of it. You won't be using the power rule on it or doing anything like that. The only variable that we're looking at in this problem is right here, this t value. And so that 1 over t piece is going to be something we have to consider as a rewrite to do. But the first move here before we're even ready to do that is we actually want to go ahead and distribute this c up front here into this equation back here. So rewriting that, we would end up with the cosine of, and then I would have c times 1 over t from multiplying the c into that first piece right there, and then minus 3c squared. C times c is going to give us 3c squared. So the first move to get yourself going on a problem like this is to distribute that number through the inside parentheses there. We definitely don't want multiple layers of parentheses if we can avoid it. The next thing that we want to take note of is, again, this 1 over t piece right here. That is a rewrite, an algebraic rewrite that we have to look out for whenever we're taking a derivative. So anytime you have a number over x to a power, you're always going to rewrite that as whatever that number is times x to the negative power. So an example of that would be something like 5 over x to the third. You would want to rewrite as 5x to the negative 3. One that confuses a lot of people is when you get something like 7/8 x to the fifth here like this. People want to attach that 8 and the x when in reality this 7 and the 8 are what's attached here. That's just a fraction. And so that fraction stays 7 over 8, and as you rewrite that x to the fifth on bottom, you would bring it up to the top and make it negative. So that's the rewrite that we also need to handle. So the first move again was just to distribute the c through those back set of parentheses there. Our next move before we're even ready to take a derivative is going to be to do a rewrite here. So we're looking at r of t equals the cosine of, and again c is just a number, and that t has an unwritten 1 as a power, so we rewrite that as t to the negative 1, and then the minus 3c squared just comes along for the ride. So now what we're looking at is really the derivative of the cosine function with a bunch of stuff inside it. And so the derivative of cosine is a special case derivative. So if my f of x equals the cosine of x, the derivative of the cosine of x is equal to negative sine x. This cosine behaves just like we talked about with the natural log, just like we talked about with e to the x on those earlier problems. As soon as that is anything more than just an x inside our cosine right there, this will become a chain rule problem. And so what you can see is there is for sure a whole bunch of stuff inside that cosine function right there. It's not just our simple little x, and so that tells us immediately that we're going to need to do a chain rule on this problem. So our chain rule saying, or at least my chain rule saying, is d in times d out, the derivative of the inside piece times the derivative of the outside piece. So if I, again, break this down into smaller bite-sized chunk, my inside piece is what's inside my cosine right there. So that would be c times t to the negative 1 minus 3c squared. My outside piece, as far as my derivative is concerned, is the cosine of a bunch of junk. So we're really just taking the derivative of that cosine piece, and while there is stuff inside that cosine, all that stuff is going to stay the same. We're not going to touch it when we go to take that derivative of the outside piece there. So we'll go back to our n right now, and we'll do our dn right here. So that dn is going to require us to do our power rule. And we're using the power rule on that t. Remember that c is just a number. It's a constant. You treat it like a 5. And so when you're looking at that problem right now, don't worry about the c. It's coming along for the ride. You just want to worry about the t. So our power rule says bring the power down and then subtract 1 from the power. So I'm going to bring this -1 down and multiply it by the c there. So I'm going to end up with negative c t, and then -1 minus 1 is going to give me a -2 power. Be super careful on those negative exponents. A lot of people mess them up and go the wrong way on it. And so then from there, I go ahead and the back end piece here, this minus 3c squared, that is all just a constant. It's -3 is a number, c squared is just a number. So it's a crazy looking number, but it's no different than asking you to take the derivative of any other constant. And remind yourself, the derivative of a constant, a number by itself, is always 0. So essentially, we have a plus 0 going on at the end there. So our dn is really just that front piece, the -c times t to the -2. Moving on to the next piece, our outside piece, our d out right now. Well, the derivative of the outside, we're just worried about the cosine piece here. So the derivative of cosine, that was our special case. So that's going to become negative sine. And then you just want to leave alone all that stuff on the inside that you already took the derivative of on part 1 there. So minus 3c squared, all that stays the same. So I now have a d in, I now have a d out, and that's all I needed to accomplish my chain rule. So I can go over to my r of t right now, and I'm ready to take the derivative. So r prime of t says, first go grab the derivative of the inside. So that's going to be our negative c times t to the -2. That's our d in right there. And then we'll multiply it by our d out. So our chunk right here, this would be negative sine of, and you leave all that junk alone on the inside that you already took the derivative of. And then that would be your final answer. Make sure when you're doing this that you wrap everything in a set of parentheses. One of the common mistakes that people do on a problem like this is they leave out that parenthesis right there in front of the sign, and when they grade these things, they're more than happy to read that as a minus sign if you don't have the parenthesis there telling them that you really mean for it to be multiplied. So plug your pieces in. Just make sure you learn your special cases, learn your algebraic rewrites, and then just break it down into bite-sized chunks.